Good morning student. Welcome to Digital Electronics video lecture class. I am Jyotirmoy Sahu, lecturer of ETC. So in previous class we have already finished chapter 2, that is combinational logic circuit. So today we are going to learn the new chapter 3, that is sequential logic circuit. So first of all we have to know about sequential logic circuit. So combinational circuit produces an output based on input variable only. So if we are giving input to the combinational circuit, then it gives output. The combinational circuit takes input and gives the output. So it is output based on input variable. So but sequential circuit produces an output based on current input and previous input variables. So here in the sequential logic circuit, the output depends upon the current input as well as the previous input variables. That means sequential circuits include memory elements which are capable of storing binary information. That binary information defines the state of the sequential circuit at that time. So this is the circuit diagram of a sequential circuit. So here two main components are present. One is combinational logic circuit and the other one is memory element. So here we are giving external inputs to the combinational circuit and it gives external outputs. So here the input is given from memory element to the combinational circuit through current state, and the outputs of combinational circuit is connected to the memory element through next state. So here the logic diagram or the circuit diagram of a sequential circuit. So then come to latch. What is a latch? So a latch is a simple memory element where a bit of information is logged or latched. We cannot feed the digital information to digital circuit. So a latch is capable of storing one bit of information. Then come to flip-flop. What is a flip-flop? Flip-flop is popularly known as the basic digital memory circuit. It has two states as logic 1, that is high state, and logic 0, that is low states. A flip-flop is a sequential circuit which consists of a single binary state of information or data. So the digital circuit is a flip-flop which has two outputs and are of opposite states. It is also known as a bistable multivibrator. So flip-flop is a basic digital memory element with two stable state. Its state can be changed by applying proper triggering signal. So what do you mean by triggering? Triggering means the process of applying control signal to change the state of flip-flop is called triggering. If we are applying some control signal to change the output or to change the state of a flip-flop, then it is known as triggering. So this is all about flip-flop. Then come to types of flip-flop. So there are four types of flip-flop. First one is RS flip-flop. Second one is JK flip-flop. Third one is D flip-flop. And fourth one is T flip-flop. So first come to RS flip-flop. RS means reset and set flip-flop. Reset means 0 and set means 1. So here SR flip-flop is similar to SR latch. Expect clock signal and two AND gates. The circuit responds to the positive edge of the clock pulse to the inputs S and R. So it is a simplest type of flip-flop. It can be constructed using either NAND gates or NOR gates. So here this SR flip-flop or RS flip-flop is constructed using only NAND gates. So here 4 NAND gates are used to construct the RS flip-flop. So this is the truth table of a RS flip-flop. So here 2 inputs S and R are present and the 2 outputs are Qn and Qn plus 1. So Qn is the present state and Qn plus 1 is the next state. So when both the inputs are 0, at that time the outputs are either 0 or 1. That is, no change. No change occurs in output. Then when S is 0 and R is 1, when S value is 0 and R value is 1, at that time the Qn value is 0. Here Qn 1 plus 1 here Qn plus 1 value is 0, and for next combination Qn value is 1 and Qn plus 1 value is 0. So here the Qn plus 1 value is reset. So in both the case the Qn plus 1 value is reset. Reset means 0. So when S is 0 and R is 1, in this case the output value Qn plus 1 value is reset. That means it is 0. Then next combination is when S value is 1 and R value is 0. At that time the Qn plus 1 value is set. Set means 1. Then for last combination, that means when both the values of S and R are 1, when both S and R is 1, at that time the output is invalid or not allowed condition. Here the output is invalid or not allowed condition. So this is the truth table of RS flip-flop. So condition number 1 is, in SR flip-flop, when S equals to 0 and R equals to 0, the next output means Qn plus 1 will be same as the previous output, that is Qn. So here Qn plus 1 is equal to Qn. That means next output is equal to previous output. So there is no change in output state. Then condition number 2 is, when S value is 0 and R value is 1. When S value is 0 and R value is 1, then the output will go to reset state, that is 0. That is 0 irrespective condition of previous output. Then condition number 3 is, when S equals to 1 and R equals to 0, the output will go to set state, that is the next output Qn plus 1 is 1. It is set irrespective of the previous output condition. Then the last condition is, when S equals to 1 and R equals to 1, then both the output Qn and Qn plus 1 tends to be same level, which is not allowed or invalid condition. So here when S equals to 1 and R equals to 1, for this combination or for this value, the Qn plus 1 is invalid condition. So that's all. Thank you.